2.2. Let's introduce some basic statistical concepts with R. 2.2.1. Introduction. As we're not going to collect data, we're going to simulate them. In the following part, we're going to work with simulated data in order to understand basic but important statistical concepts such as the notion of sample, distribution, mean, standard deviation. Let's simulate some data. Suppose we have a population with an average waist mu equal to 85 and the standard deviation associated with that population is sigma equal to 2. Please note that in a real-life situation, you will never know mu nor sigma. Let's simulate a sample of 20 people according to a normal distribution with mu equal to 85 and sigma equal to 2. To do so, we use the rnorm function, then we store the results in a R object, named A. With that function, we generate randomly realizations of a normal distribution. To use that function, we have to specify the size of the sample, the value of mu, and the value of sigma. This rnorm function is particularly important. To visualize the values, just write the name of the object in which you have stored the data. If you want to get a graphical representation of these values, you can use the plot function. As you can see, in order to study the distribution of these values, this kind of representation is not really useful as the x-axis represents the position of the value in the vector A, which is not really informative. To have an idea of the distribution of these values, we're going to represent them on the x-axis and we're going to assign all their y-axis coordinates to 0. To do so, we're going to generate another R object with 20, 0, by using the rep function. Here, we have generated a vector of 20 zeros, that we have called B. Then we're going to plot the two sequences of numbers, on the x-axis, and on the y-axis. Here, the arguments of the plot function consist in the two series of values. Once the data plotted, you can also get some basic numerical indicators with the summary function and the mean function, two really important functions in R. When you look at the output of the summary function, Q, U stands for quartile, and as you can guess, a second quartile of a series of numbers is the median. By definition, the value that separates the series of values into two equal parts. It's an indicator of dispersion while the mean is an indicator of position. Now, we're going to calculate manually the median to have a better idea of what it represents, then we're going to add it to the previous graphical output. To do so, we first sort our series of numbers, we take the two numbers in the middle, at the position 10th and 11th of our sorted series, and calculate their average in order to get the median. With the abline function, we add a red vertical line to our previous graphical output, defined by its x-axis which is set to median. If our sample consists of an odd number of people, here 21, the only thing that changes is the way the median is obtained. Another way of looking at the notion of distribution is by using the concepts of boxplot and histogram. Here, we simulate 200 people, and we represent their distribution using a boxplot and the boxplot function, which provides some kind of graphical representation of the summary function. Here, we simulate 200 people, and we represent their distribution using a histogram and the hist function. Exercise. In order to get used to other distributions, why don't you try by yourself with the chi-square distribution, or the F distribution? To do so, have a look at the help page of the norm function in the documentation. Then look at the section C also, and click on the ad hoc link. Let's now have a look at the normal distribution.